Have you ever wondered how to find the highest or lowest point of a function within a specific range? That is exactly what we are tackling today, absolute extrema. In this video, we will uncover how to identify the maximum and minimum values of a function on a closed interval. From critical points to boundary checks, I will walk you through the entire process and show you how these concepts are used in real-world optimization problems. Let us jump right in. Now, before you can find the absolute extrema of a function, all that you have to do is to first of all find the critical point of the function. Then afterwards, you evaluate the function at all critical points and endpoints, and then you take the largest and smallest of these values. So we have an example to explain what we are talking about. So the first question is we have to find the absolute max and min values of our function, and afterwards using the interval 1 and u squared. Okay, so let's solve this question. So we have f of x to be equal to 10x, then 2 minus ln of x. So first of all, you have to find a critical point. Now, to find a critical point, the first thing to do is to find the derivative of your function. So let's differentiate our derivative. So let's differentiate our function. So f prime of x, we have to use the product rule since we have two separate functions. So using the product rule, we have to use f of g prime plus g of f prime. So our f prime of x, first of all, we have our f, which is 10x, and we differentiate our g. So if we differentiate g, if we differentiate 2, it goes to 0, so minus, and if we differentiate ln of x, we have 1 out of x. So we have this, plus our g, so g is all of this, so we have 2 minus ln of x multiplying our f prime, and our f prime, if we differentiate 10x, we have just 10. So f prime of x is, now this x, I'll cancel this x, so we have negative 10 over here. Then if we distribute the 10 over here, we are going to have positive 20, then minus 10 ln of x. So our f prime of x is negative 10 plus 20, that is positive 10 minus 10 ln of x. Now, critical point is where the derivative is either undefined or 0. So in this case, there is no x value that will make this function undefined. So the next thing to do is to just set f prime of x to be equal to 0. So this implies that we want 10 minus 10 ln of x to be equal to 0. So we can have 10. If we send this to the right hand side, it becomes positive. So to find x, we can divide each side by 10, here by 10. Let's continue right here. So if we do that, we have 10 out of 10 is 1. So we just have ln of x here. Remember, to find x, you have to introduce the inverse of natural logarithm, which is exponential. So you introduce exponential in both sides, so you just have e then ln of x. In this case, e to the 1 is e, and e ln of x. Remember, I said e and logarithm are inverses of each other, so e will cancel ln, so you just have x. So our critical point that we are looking for is x. So x equal to e is the only critical point we have. So this is the only critical point we have. So we've been able to find a critical point. The next one is to evaluate f at all the critical points and the end points. So now we have to find f of e. We are evaluating now the critical point. So wherever we see x, we have to replace with e. So we have 10e 2 minus ln of e. So we have 10e 2 minus, now ln of e, remember, is just 1. So this is just 10e. Now let's consider the endpoint. For the endpoint, we have 1 and e squared. So let's first tackle 1. So for 1, we have 10 multiplying 1, then 2 minus ln of 1. So 10 by 1 is 10, 2 minus, now ln of 1 is 0, so we just have 2 minus 0, so this gives 20. So we've gotten 10e over here and 20 over here. So the next thing to do is to find the last one, which is f of e squared, this e squared right here. So in that case, wherever we see x, we have to replace with e squared. So we have 10 e squared then 2 minus ln of e squared. Remember, ln of e squared can be written as, remember the properties of logarithm, the 2 can come down, so we just have this. Now ln of e is 1, so if you multiply 1 by 2, we get 2. So 2 minus 2 is 0. So over here, all that we have is just times 0, so this gives 0. So we have 3 values, and now we have to select which one is the biggest and the lowest. So in this case, we can say that our absolute max is between 10e and 20. Which one is bigger? Now remember, e is 2.7 something, right? It's approximately 2.7 something. So if you multiply it by 10, we get 20 point something, which is absolutely bigger than 20. So absolute max is 10e and absolute min is 0. So this is the bigger value and this is the smallest value. So the absolute extrema is what we just found. So the absolute mass is 10e, and where does it occur? It occurs when s is equal to e, and the absolute minimum is 0, and it occurs when s is equal to e squared. Okay, let's look at a different example. So with this example, first of all, we find the critical point, and in finding the critical point, we have to find the first derivative. So f prime of x, if we differentiate this, we have 2x. There is no x value that will make this undefined. Whenever you put in x value, you get a result, right? So the next thing to do is to set f prime of x to equal to 0, which implies 2x is equal to 0, which implies s is equal to 0. One thing that I didn't say over here is whenever you get a critical point, you have to check to see if it lies within the range that you are given. Now over here, we got x is equal to e. Now clearly, you can see that e is between 1 and e squared. You know, the range is 1, e is 2.7 something. So we have 8 point, e squared is 8 point something, right? Let's say 8.4 presumably. So if we have e, which is 2 point something, it's within this range, so it means it's indeed a critical point. So you have to pay attention to that. In this case, when we have x is equal to 0, now 0 is within negative 1 and 2. So we can see that indeed x is equal to 0 is a critical point. Now, since this is a critical point, we can go ahead to evaluate at f of 0. So f of 0 is just negative 1 plus 0 squared, and this is equal to negative 1. And we evaluate at the end point, so end point is negative 1 and 2. So f of negative 1 is just negative 1 plus negative 1 squared, which is minus 1. Negative 1 squared is 1, so this simplifies to 0. And f of 2 is negative 1 plus 2 squared, and this will give you negative 1 plus 4, which is 3. So we have these three values. So now we have to just choose between them, which one is the highest and which one is the lowest. So looking at this, the absolute max is 3, and we consider it occurs at where do we get 3 when x is equal to 2? So we say it occurs at 2, and absolute mean is negative 1. Remember, negative 1 is lesser than 0, and it occurs at x is equal to 0. Okay, let's look at a third one. Okay, so with this question, the same idea. First of all, we differentiate this, and if we differentiate this right here, what do we get? Remember from the previous video, if we differentiate this, we have negative a then cotangent of x. So we have to set this equal to 0. So we have negative secant s cotangent s equal to 0. So this basically means we have equal to 0 or cotangent s is equal to 0. Now negative, if we divide both sides by negative, the negative goes away. We have to note cosecant s is the same as, this is the same as 1 over sine of x, and cotangent is the same as cosine of x out of sine of x equal to 0. The idea is, what x value will give you 1 over sine of that value to be 0? There is no value of x that will satisfy this equation. Basically, let's say we cross multiply, right? Cross multiply this. We will just get 1 equal to 0 times sine x. This is just 0. This equation can never be satisfied. So over here, we can't have any critical point. No critical point over here. In this case, if we cross multiply, we're going to get cosine of x. Cosine of x is equal to 0, because sine x times 0 is 0. Now, we know an x value that will give us 0. But note that there is no x value. We don't have a single value that will satisfy this. We have multiple. Now, we know that when x is equal to pi over 2 or 90 degrees, we can say that cosine is 0. But we have multiples, right? So our x is pi over 2 plus multiple of pi, where our n is just all integers. So all integers is going to satisfy this condition right here. So when we have pi over 2 plus n pi, if you put it over here, it should satisfy. So basically what this means is when we have pi over 2 is 90, right? So we have 90, then when n is, for instance, 0, we have just 90 degrees, cos 90 is 0. When n is 1, we have 1 times pi, which is just 180, cos 270 is also 0. So if we keep on multiplying everything, we are going to get 0. If we choose the negative aspect as well, you also get 0. But we have a condition. We have this interval. So negative pi over 3 is negative 60. This over here is negative 60. And 2 pi over 3. Now 2 pi over 3 is 120. So it means that our x should be between this range. So yes, all this will give you 0, but it should be between this. Okay, so now let's say n is equal to, when n is equal to 1, we get pi over 2 plus pi, which is 90 plus 180, which is 270. So we can see that this exceed 120, so we can't even use it, right? We cannot use this. Now when n is equal to 2, obviously it's also going to exceed 120, so we can't use it. So now let's decrease. When n is 0, we just have pi over 2. Pi over 2 is 90 degrees, which is between this. So we can say s is pi over 2 is accepted. When we go to negative 1, when n is equal to negative 1, we get pi over 2 minus pi, which is just minus 90 minus pi over 2. And minus pi over 2 is minus 90 degrees, which is not in this domain. So we can't have that one as well. So all that we can say is the only x value that satisfies this condition is pi out of 2. So our critical point is pi out of 2. So now we have to evaluate our g of x at the critical point and the end point. So we have to find g of pi over 2. So g of pi over 2 is pi over 2. But we know this is the same as writing 1 out of sine. So we have 1 out of sine of pi out of 2. And what is sine 90? Sine 90 is 1. So we have 1 out of 1, which is equal to 1. So this is our first value. And then we have to consider the end point. So we have g of negative pi over 3. So this is negative pi out of 3. So we have 1 out of sine negative pi out of 3. And this is equal to, so 1 out of sine pi out of 3 negative. Remember, negative pi out of 3 is negative 60. If you want to evaluate it at the positive end, all that you have to do is to add 360 degrees to it. So this is just 300 degrees. So in other words, what you are doing is, instead of finding sine of negative pi over 3 is the same as finding sine of 300 degrees. I don't know if it makes sense. So this is just 1 out of, now sine of 300 degrees is negative root 3 out of 2. So basically, if you find a reciprocal, this is negative root 3 out of 2. So we have the second value here. So let me do the third one. For the third one, you just have to find g of 2 pi out of 3 and this is 1 out of sine of 2 pi out of 3, and sine of 2 pi over 3 is just root 3 over 2, so we have 1 over root 3 out of 2, which is basically 2 over root 3. So we have these three values, and we have to select which one is the maximum and which one is the minimum. So looking at the 3, which one do you think is the maximum? Okay, so in this case, the absolute max is 2 out of root 3, because 2 out of root 3 is approximately 1.15, so that's the maximum, and absolute mean is, the absolute mean is 1. So I hope this is clear. Okay, now let's look at another question. So for this question, let's say we have g of x is equal to sec of x between minus pi over 3 and pi out of 6. So we use the same idea. We differentiate. Now if we differentiate secant, you get sec x tan x. So you have to set this equal to 0. So sec x tan x equal to 0 is basically sec x equal to 0 or tan x is equal to 0. Sec x is 1 out of cosine. Tan is sine of x out of cosine of x. So looking at this, we are going to, if we multiply, we're going to have 1 equal to 0. So we can have no critical point here. Over here, if we multiply, we have sine x is equal to 0. So we have to find the x values that will satisfy this condition. So when x is equal to, sine of 0 is 0, right? And also when x is equal to 180, we are going to get sine of 180 to be 0. So we can say that the x values that do satisfy this condition is when you have n pi, where n is basically all integers. But now we have to use the condition that we have. We have the condition negative pi over 3 x, then pi over 6, which is just negative 60 to 30. So now let's say when x is equal to 0, is 0 in this domain? Yes. So it means when n is equal to 0, we get 0 times pi, which is 0. 0 is in this domain, so it means they satisfy. Let's see if we are going to get another one. If n is equal to 1, we get 180, right? 1 times pi is 180, and 180 is 630, so we can't use that. When n is equal to negative 1, we get negative pi, which is negative 180, which is also out of this range. So the only critical value that we have is s is equal to 0. So now we have to find g of 0. G of 0 is sec of 0, which is 1 over cosine of 0. And 1 over cosine of 0, we know cosine of 0 to be 1, so we just have 1 here. And now we have to find g of the endpoint. So g of negative pi over 3 is 1 over cos of negative pi over 3. Remember, this is the same as if we don't want the negative, we have to find negative pi over 3. We can add 2 pi, which is 360, and this is equal to 5 over 3 pi. So instead of finding cos negative pi over 3, you can find cos 5 pi over 3, and it should be the same thing. So cos 5 pi over 3 is 1/2. So 1 over 1/2 is just 2. So we have our second value. For the third, we can find the last critical point, the last end point, which is just pi over 6. So we want 1 over cosine of pi over 6, and this is now cosine of pi over 6 is just root of 3 over 2. So in this case, we have 2 out of root of 3. So we have these 3 points, and we have to select the absolute max and min. So absolute max is, in this case, the absolute max is 2, and absolute min is 1. So you can always use the reference angle. So as we were doing, right, you can always use this angle. If you remember, we had this, we had this to be 30, we had this to be 60, we had this to be 45, we had this to be 45, we had 1, 1 and root 2, 1, 2 and root 3. This was always 90, this is always 90. So for instance, when we come over here, we want to find, how do we find cosine of pi over 6? Now pi over 6 is 30 degrees, so we have to use the first triangle, right? So cos is adjacent of a hypotenuse. So adjacent of 30 over here is root 3, so we have root 3 out of hypotenuse, which is 2. So that's why we had root 3 out of 2 over here. So you have to use these reference triangles to always solve your problems. Now let's look at the last question. We have to determine the critical point. Okay, so to determine the critical point, remember, we just have to differentiate, right? So y prime is, now if we differentiate ln of x plus 1, if we differentiate what is the parenthesis, you have 1, you divide by what is inside it, and we have x plus 1, then minus. Now remember, if we differentiate tan inverse, you have 1 over 1 plus s squared. So in this case, we can find the LCD. So instead of finding the LCD, let's first of all remember, critical point is where the function is undefined or equal to 0, and we don't have any s value that will make this undefined. So we just have to set this equal to 0. So in doing that, we can send this to the right hand side and becomes positive. So now we can just cross multiply. You can just cross multiply this and that. So we have 1 plus s squared is equal to x plus 1. Then we have s squared. Then we send this to the left hand side. So we have negative x. Remember, we already have plus 1 here, so plus 1. And if this crosses, it becomes negative 1. So minus 1 equal to 0. And this is s squared minus s is equal to 0. So now we can factorize x out. And if we do that, we just have x minus 1 inside the parenthesis. So this basically means x is equal to 0, or x minus 1 is equal to 0, which is x is equal to 1. So the critical point of f is x is equal to 0 or x is equal to 1. And that is a wrap on absolute extrema. You now have the tools to find the highest and lowest point of a function with confidence. If you enjoyed learning with me today, make sure to subscribe for more videos like this. And feel free to share your thoughts or questions in the comments below. Thanks for watching. I'll see you in the next one.